Hi there, welcome to High School Maths. Today we're going to be looking at distance, speed and time, and we're going to be looking at mixed examples using the distance, speed, time triangle. So here we've got distance, speed, time triangle. This is an easy way to remember the different formulas for distance, speed and time. It's in alphabetical order, so you've got D at the top, S and T at the bottom, and you've got this little cross in the middle, which will help you remember the different kind of formulas. So let's have a look at how this works. So the first question, as the first formula, we're going to start off with distance, and D equals, what we do is, if we're looking for distance, we cover up distance and see what's left over, which is speed times time. So D equals S times T. If we want to find speed, we cover up speed. And speed equals distance over time. And lastly, if we want to find time, we cover up time, and that leaves time equals distance over speed. Now these are your three formula that you need to know. Pretty straightforward, they're all linked to each other, and the distance, speed, time triangle helps remember that. So we're going to go over a few examples using this and some decimal times. First one, find the speed of a car that travelled 40 kilometres in half an hour. So it's asking for the speed or the average speed of the journey. Speed equals distance over time. So we need the distance, which was 40 kilometres, and we need time, which was half an hour. Now, when you think about units for speed, it's always, when you're talking about cars, miles per hour or kilometres per hour. Okay, so our time has got to be in hours. Half an hour, well, half is 0.5. Half an hour is 30 minutes, but we don't want to put 30 minutes. So we want to put it as 0.5 hours, half an hour. So 0.5. 40 divided by 0.5, you can do that quite quickly in your head. If you divide by a half, that doubles the answer. So we get 80 kilometres per hour. Okay, make sure you check your units are consistent. Kilometres for the distance, hours for the time. Kilometres per hour. And that's your answer. Okay, so let's have a look at the next example. How long would it take a plane flying at an average speed of 250 kilometres to travel 875 kilometres? How long? That's talking about time. So our time formula is distance divided by speed. Now the distance, again, nice and easy, that's 875 kilometres. We don't need to put the units in the actual working, we only need the units in the final answer. The time, sorry, the speed is 250 kilometres per hour. So 875 divided by 250. Now you could do that without a calculator. 3 times 250 is 750, and then we did 125. To make 875, so it's 3.5 or 3.5 hours. Typically, we don't leave things as decimal hours, we want to convert it to hours and minutes where possible. So that's 3 full hours. 0.5 of an hour is half an hour, so 3 hours and 30 minutes. Okay, let's have a look at some more complex examples on distance, speed and time with some more trickier times and some kind of more involved questions. So we've got the first example here. Darren left his home at 9:45 a.m. He travelled 180 miles at an average speed of 40 miles per hour. What time did he arrive at his destination? Alright, if we look at what we've got here, he leaves his home at that time. He travels, this is his distance, at an average speed here. So we've got a distance and we've got a speed. What we want to figure out is how long did that journey take? What was the time of that journey? So the time is the distance divided by the speed. The distance is 180. The speed is 40. And again, we can just count that up. We can do that without a calculator. So practice those non-calculator skills. How many 40s fit into 180? Well, 4 40s are 160. And then we've got another 20, so that's 4.5. So the time was 4.5 hours, or 4 hours and 30 minutes. Now that's not quite finished. What I was looking for is what time he arrives at his destination. He sets off at 9:45 a.m. He takes 4 hours and 30 minutes, so I'm going to add on the 4 hours. That takes me to 1:45 a.m. p.m. And then we've got to add on the 30 minutes. And if we add on the 30 minutes, that'll take us to 2:15 p.m. So that's the time he would arrive at his destination, 2:15 p.m. So there's a little bit more work in terms of stepping out the time to get to his final answer there. And the last question we're going to go over is Katrina went on a run. She ran for 36 minutes at an average speed of 7.4 kilometers per hour. How far did she run? Okay, how far means distance. So distance equals speed times time. The speed, our average speed, is 7.4 kilometers per hour. Her time, this is where you've got to be very careful. Her time was given in minutes, but it's miles per hour. So we've got to convert this 36 minutes into hours. Okay. Now, if you think about it, it's not that difficult. A full hour is 60 minutes. A tenth of an hour, so 0.1 of an hour, is 6 minutes. 0.2, 12. 0.3, 18. So we've got to figure out how many sixes fit into 36, and that would be 6. So 36 minutes is 0.6 hours. And if you want to step that out, it's quite easy. 0.1 hours is your kind of baseline. That's 6 minutes. So you can keep kind of doubling that. 0.2 hours, 12 minutes. Just keep adding on 6 minutes. 0.3 hours is 18, and so on. So we can do that until we get up to 0.6, which would be 36 minutes. So the time that we want to use here is 0.6. 7.4 times 0.6. And that gives you 4.44, and it's a distance, so kilometers was the distance unit. An alternative method, if you had a calculator for converting 36 minutes, so if it was a calculator question, we could just say, well, that's 36 out of 60, which is 36 divided by 60, and that would also give you 0.6 if you type that into a calculator. So you could do that as an alternative. It's good to know the non-calculator version as well, just in case it comes up when you've not got a calculator at hand. So that's how you deal with mixed speed, distance and time questions. Hopefully you found that useful. For other videos and resources, please visit highschoolmaths.co.uk, and if you liked the video, click that like button and subscribe, and please remember and share the video. Thanks for watching, and have a math magical day.